Hello everyone, my name is NAMGYAL SHERPA, student of NAMGYAL Government College, BSc Physics Department, is presenting a short presentation on the topic ultrasound and types of microprocessor, which was given to us by our respected teacher C.P. Khatiwala sir as our assignment for term paper 2. Before representing my topic, I would like to express my special thanks and gratitude to my teachers who gave me a golden opportunity to do this wonderful project on the topic ultrasound and microprocessor, which also helped me in doing a lot of research, and I came to know so many things. I'm really thankful to them. Secondly, I would like to thank my friends who helped me in finishing this project in a short period of time. Now I would like to start with the introduction part. I would like to start with the ultrasound. Ultrasound or ultrasonography is a medical image technique that uses high frequency sound wave and their echoes. The technique is similar to the echolocation used by bats, whales and dolphins, as well as sonar used by submarines. In other words, ultrasound is defined as the mechanical longitudinal pressure wave with a frequency exceeding the upper limit of human hearing, which is 20,000 Hz or 20 kHz. Medical ultrasound is greater than 2 MHz. It may be 2 MHz to 16 MHz. The block diagram of ultrasound imaging. 3D ultrasound imaging has drawn great attention in recent years. This figure shows a functional block diagram of an ultrasound imaging system. The construction of ultra B mode image involves capturing the echo signal returned from tissue at the surface of piezoelectric crystal transducer. And now we are going to talk about the ultrasound machine. The basic ultrasound machine has the following parts: transducer probe that sends and receives the sound waves. Second, central processing unit, which is also called CPU. CPU changes the amplitude, frequency and duration of the pulse emitted from the transducer probe. Number 3, display. Display the image from the ultrasound data processed by the CPU. And third, keyboard or cursor. Input data and text measurement from the displays. Disk storage device like hard floppy CD, they stores the acquired image. And last, printer prints the image of the displayed data. In ultrasound, the following events happens. The ultrasound machine transmits high frequency 1 to 5 MHz sound pulse into your body using a probe. The sound waves travel into your body and hit a boundary between tissues. Number 3. Some of the sound wave gets reflected back to the probe, while some travel on further until they reach another boundary and get reflected. Number 4. The reflected waves are picked up by the probe and relayed to the machine. And number 5. The machine calculates the distance from the probe to the tissue of organ boundaries using the speed of sound tissue and the time of each echo's turn, usually on the order of millions of a second. Number 6. The machine displays the distance and instance of the echoes on the screen, forming a two-dimensional image. In a typical ultrasound, millions of pulses and echoes are sent and received each second. The probe can move along the surface of the body and angled to obtain various views. The history of ultrasound. In 1880, French physicist Pierre Curie and his elder brother Paul Jacques Curie discovered the piezoelectric effect in certain crystal. Paul Langevin, a student of Pierre Curie, developed piezoelectric materials which can generate and receive mechanical vibration with high frequency. Therefore, ultrasound. During World War I, ultrasound was introduced in the Navy as a means to detect enemy submarines. In the medical field, however, ultrasound was initially used for therapeutic rather than diagnostic purposes. In the late 1920s, Paul Langevin discovered that high-power ultrasound could generate heat in bone and disrupt animal tissues. As a result, throughout the early 1950s, ultrasound was used to treat patients with minor disease, Parkinson's disease, and retinitis arthritis. Diagnostic application of ultrasound began through the collaboration of physicians and sonar engineers. In 1942, Carl Dusik, a neuropsychiatrist, and his brother Friedrich Dusik, a psychiatrist, described ultrasound as a medical diagnostic tool. In 1976, the first ultrasound method coupled with Doppler measurements were commercially available. Piezoelectric effect. Ultrasound wave can be generated by materials with a piezoelectric effect. The piezoelectric effect is a phenomenon exhibited by the generation of an electric charge in response to a mechanical force applied on certain materials. Conversely, mechanical deformation can be produced when an electric field is applied to such material, as known as the piezoelectric effect. Both natural and human-made materials, including quartz crystal and ceramic materials, can demonstrate piezoelectric properties. Recently, lead zirconate trinate has been used as piezoelectric materials are also under development. Individual piezoelectric materials produce a small amount of energies. However, by stacking piezoelectric elements in layers in a transducer, the transducer can convert electric energy into mechanical oscillations more efficiently. The mechanical oscillations are then converted into electric energy. Definition of microprocessor. A microprocessor is a multi-purpose, programmable clock-driven, register-based electronic device that reads binary instruction from storage device called memory, accepts binary data as inputs, and processes data according to those instructions and provides results as output. Microprocessor is a silicon chip which includes ALU, register, circuit and control circuits. Microprocessor has 40 legs. Now we have came to the types of microprocessor. Number 1. Vector processor. A vector processor is designed for vector computation. A vector is an array of operands of the same type. Consider the following vectors. Suppose vector A equals to A1, A2, A3, AN. Vector B, B1, B2, B3 till Bn. Vector C is equals to vector A plus vector B, which is equals to C bracket C1, C2, C3, Cn. A vector processor add all the elements of vector A and vector B using a single vector instructions with hardware approach, as we can see above. Examples of vector processor are DEX VEX 9000, number 2 IBM 390BF. Array processor or SIMP processor. Array processors are also designed for vector computation. The difference between array processor and a vector processor is that a vector processor uses multiple vector pipelines, whereas array processor employs a number of processing elements to operate in parallel. An array processor contains multiple of ALU. Each ALU is provided with the label memory. The ALUs together with the local memory is called a processing element PE. An array processor is a single instruction multiple data processor. Thus, using a single instruction, the same operation can be performed on an array of data, which makes suitable for vector computation. Scalar and superscalar processor. A processor that executes scalar data is called scalar processor. The simplest scalar processor makes processing of both integers as well as floating points member. It can contain an integers ALU, a floating point unit FPU on the same CPU chip. A scalar processor may be RISC processor or CISC processor. A superscalar processor has multiple pipelines and executes more than one instruction per clock cycle. Examples of superscalar processors are Pentium, Pentium Pro, Pentium 2, Pentium 3, etc. RISC and CISC processor. RISC stands for Reduced Instruction Set Computer and CISC stands for Complex Instruction Set Computer. There are two approaches of the design of the control unit of a microprocessor, that is, hardware approach and software approach. As we have already discussed that RISC stands for Reduced Instruction Set Computer. RISC is the microprocessor, and as the name indicates, it performs a smaller number of computer instructions that has a high speed to operate. It works on a fixed instruction format to keep less than 100 instructions to be processed with a register-based instruction used by a simple addressing nodes. The load store is the only instruction used to access the memory, as it is a compiler development mechanism. CISC processor. CISC stands for Complex Instruction Set Computer, as we have already discussed above. CISC is the kind of chip that can easily programmed and makes the best efficient use of memory. The main motive of CISC is to make compiler development easy and simple. There is no need for the mechanic to generate instruction, for the processor of CISC eliminates the need. The next one is Digital Signal Processor, DSP. DSP is specially designed to process signal. They receive some digitized signal from information, perform same digitized signal information and give the result to an output device. They implement differentiation, complex fast Fourier transform, etc. using hardware. Example, Texas Instruments TM-S320C25, Motorola 56000. Symbolic processor. Symbolic processors are designed for expert system, machine intelligence, knowledge-based system, pattern recognition, text retrieval, etc. Symbolic processors are also called Lisp processor or Prolog processor. Bit slice processor. The processor of desired word length is developed using the building blocks. The basic building block is called bit slice. The building includes 4-bit ALU microprogram sequence, carry, look, ahead, generator, etc. The word slice was used because the desired number of ALU and other computation were used to build an 8-bit, 16-bit or 32-bit CPU. Transputer processor. In a multiprocessor system, a transputer is a specially designed microprocessor to operate as a component processor. Transputer were introduced in late 1980s. They were built on VLSI chip and contained a processor. Communication link was to provide point-to-point connection between transputers. And now, graphic processor. Graphic processor are specially designed processor of graphics. Intel has developed Intel 740 3D graphics chips. It is optimized for Pentium 2 PCS using a hyper-pipelined 3D architectures with additional 2D acceleration.